Okay, 7 o'clock. We'll get started. Welcome to tonight's conservation webinar. Really excited. The topic, which garners a lot of discussion and controversy sometimes, depending on which newspaper you're reading. This one tonight is called Win-Win Options for Moose Management and Caribou Recovery. A little bit about the series. This is, I think we're probably coming up on a year and a half in terms of conservation webinars where we bring material and topics and researchers that are of interest to our members and interest to the public. So thank you all for coming. The format for these webinars is we have our presentation. Tonight we have two presenters, which is awesome. They'll present for probably 40 minutes tonight, 45 minutes, and then we'll get on to Q&A. Your questions on Facebook Live go into the comments, and on the if you're coming in on Zoom, on the Q&A function, we'll do all the questions at the end. And you can see some reminders in the chat right now. The intention of these webinars is to bring everyone up to speed as it relates to education and advocacy on issues that face fish wildlife habitat, people who hunt and fish, and sometimes even sport shooting and other avenues. With that, I will introduce our two guests tonight. Mateen Hessami is going to be going first. He's a community-based wildlife ecologist who works with Biodiversity Pathways. Mateen did his undergrad at the University of Montana with Dr. Mark Hebblewhite and did his master's at UBC Okanagan. His thesis was titled Moose Management in the Lake Revelstoke Valley, so he's intimately familiar with this issue. And then we also have Dr. Rob Serrouya, who is he's a director with the Caribou Monitoring Unit, also with Biodiversity Pathways. Dr. Serrouya's main research focus has been to test recovery options for caribou and other species by implementing broad-scale adaptive management experiments. He has worked as a large mammal ecologist in Alberta and British Columbia for over 20 years, specialized on broad-scale processes, particularly how forestry and energy extraction affects trophic interactions within ecosystems that until recently had little early cereal vegetation. How the shift in vegetation from old forests to shrubs affects the abundance and interactions among herbivores and carnivores is one of his main research interests. He currently works on boreal and mountain caribou ecotypes and focuses on how the changing dynamics of other herbivores, i.e. moose and deer, and carnivores, bear wolves and cougars, affect the survival of caribou. We've had Rob at our BCWF convention a number of times as we've kind of followed caribou recovery through the years. When we go through all the old literature and the Wildlife Digest in British Columbia, we can see this topic popping up as early as the early 70s, and the business of managing the way we take care of the land continues to come up. And this has been a long, kind of hard battle for the BC Wildlife Federation as well. So with that, Mateen, I guess you're up first. If you don't mind sharing your screen, we'll get started.
Right on. Okay. Are we systems go? Can you see my screen?
Yeah, looks good.
Okay, awesome. Well, thanks, Jesse, and thanks, BC Wildlife Federation, for having us. Both Dr. Serrouya and I are really excited to chat about this topic and the science that we have undertaken to learn more about this system. So as Jesse mentioned, this research, I came onto it, relatively late in the sense that it was for my master's, and there's been researchers who have been at this for decades prior to me coming on. But nonetheless, it was really awesome to learn about this system and work with Dr. Rob Serrouya and Dr. Adam Ford. And that's what I'm going to be talking about today. And before I get started, I want to acknowledge the traditional territories where this research took place. So the Ktunaxa Nation, Secwepemc, and Okanagan peoples have traditional territories within this area, and they've also been stewards of this landscape for thousands of years. Okay, so while this is a moose talk, it's also in a sense a caribou talk, in the sense that this management lever was applied for caribou recovery, and the management lever being an antlerless moose season. So I first wanted to introduce the plight of caribou in Western Canada, specifically in the mountainous region, so the mountain caribou. And what's been going on is the ecosystem has been transformed in the last 100 or so years from a natural state of old growth to one with things you see in this picture. So cut blocks and other disturbances such as roads. And this isn't just isolated to mountain caribou in southern BC. For caribou across North America, this exact same process, known as apparent competition, has been at play and is the reason for their decline. So when these forests are transformed to early seral forests, where no longer old growth stands and the sun is able to penetrate the forest floor and these new plants are able to grow, that is a good news story for moose and deer, which benefit from these early seral habitat conditions. And when moose and deer, as their populations start to grow, wolves and mountain lions, their populations also grow, and in consequence, they predate on caribou that didn't evolve the same defense mechanisms as moose, deer, and elk have to avoid predators. So again, habitat alteration is the ultimate reason for caribou decline. However, the proximate reason is predation on caribou at unsustainable rates. So there's a list of recovery levers that the province has employed and other places throughout North America. The primary lever and the most important to protect caribou is to stop the loss of habitat. And to do so requires reducing or stopping the amount of old growth logging, specifically for mountain caribou. The second lever to pull is to reduce predator densities to thresholds that allow caribou to recover. Another lever is maternal penning, which is kind of a last hour, emergency room step. This is currently being undertaken with the central Selkirk population that's down to just about 20 individuals. And maternal penning is a lever that helps adult females carry their calves a couple months after they're born and be released into the wild. And then there is primary prey stabilization, which is the topic or the focus of the talk today, where you reduce and stabilize primary prey populations such as moose. And the idea is by doing so, you will disperse wolves and reduce the density of wolves, as a moose in many systems in British Columbia, especially the mountain caribou system that we're talking about today, moose are the primary food source for wolves. So you can imagine if you took the grocery stores out of your town, you're likely going to leave that town or not be able to live there anymore. So a similar story with moose and this caribou recovery lever. So jumping into an important topic right off the bat, we hear often that this recovery lever for caribou, primary prey stabilization of moose, is ongoing all throughout the province. And I just want to quickly mention that is not true. So here in green is where the hunt, I say that in the past tense because this parsnip area is no longer under this primary prey management regime. So just last year, it was removed. And so Revelstoke is the only place in the entire province where cow moose can be harvested. Now in pink here are areas where there is a single cow moose tag, and you likely see this in the regulations and when you apply to LEH that there is a moose hunting option in these areas. But it's really important to emphasize that this is a single cow tag. So it's in essence this tokenistic one tag that the province has in place, because if it was to be removed, the province could no longer, if they ever needed to or wanted to, implement that LEH. And again, yellow, everything in yellow, there is no, there's not even a single LEH tag. But again, the pink, there is just a single, so one, and only now in this Revelstoke area are moose able to be harvested. Okay, so it's important when we're talking about this system to set the context and quickly discuss the timeline of moose in British Columbia. I think a lot of people don't realize that moose are relative newcomers to southern British Columbia, in the sense that prior to settler colonization, prior to large-scale forestry, moose were rather confined to this northeast corner of BC in the Peace. And this is supported by Hudson Bay trapping records, by Indigenous knowledge, that moose really only started to colonize British Columbia in the 1900s. So as you see in this figure here, moose prior to the 1860s were again isolated to this Peace region. And as forestry and large-scale predator suppression was enacted, that made conditions more conducive to moose, and moose were able to move south. And moose are now as far south as New Mexico, and they haven't been that far ever. So that's a really interesting piece about moose, is that they are expanding in areas that really puzzle ecologists. But in some of these areas, like in Nevada and Utah, they're actually doing quite well. But anyways, I just wanted to make that point that moose are relative newcomers, especially to the Revelstoke system, which is the study area of focus. And here we are. Here is our study figure map. So the Revelstoke Valley, we're referring to the management units 439 and 438. And Dr. Serrouya is going to talk about some research that's happened in the North Thompson as well. But my portion of the talk is isolated to the Revelstoke Valley. So we, in green here are the forestry cut blocks. And so forestry is the primary mechanism of disturbance in this system. Forestry is what has changed that forest state from a primarily old growth to a regenerating one. And that's allowed moose to move into this area, as well as white-tailed deer. And that's changed the predator-prey dynamic, not in favor of caribou. And I think I'll quickly mention, I briefly did on the second slide there, why caribou are not able to defend themselves, as well as moose and deer are. And that's for the fact that that's how caribou evolved. They evolved to segregate themselves from predators by being up in areas that are not conducive to wolves, and being in ecosystems where caribou were mostly the primary ungulate. So if we roll the clock back a couple hundred years, like caribou were the primary ungulate in this area. There's thought to be mountain goats and the odd mule deer, the odd moose at very low densities, but it was mostly a caribou system. And then here in the top right corner is another really important figure that we have attached to our study area that shows the amount of forest that's been cut in the last 60 years. So as you can see, there was a peak of forestry in the late 80s and 90s, and it's reduced from there. And folks may be wondering, why has that cut been reduced? So this is the annual hectares harvested each year. And there's two reasons for that. One, for the simple fact that the amount of merchantable, available, accessible timber has simply declined. So the peak of that, as I mentioned, was the 80s and 90s. And the second reason is government action regulation. So the GAR orders to protect caribou habitat. Those are the two reasons why we've seen this decline in forestry. Okay, and then here's also the Columbia North caribou subpopulation, which, since the onset of settler colonization has experienced a decline. A lot of traditional knowledge says that, there were lots and lots of caribou, and that, their hair would float down the river. And there's a lot of traditional knowledge saying that caribou were once a species hunted by Secwepemc, Okanagan, Ktunaxa peoples. However, that is of course no longer the reality. And this caribou population declined rapidly in the late 1900s, and then stabilized in the early 2000s, and has recently been increasing, and is now at about 210 individuals. Okay, so here is another timeline of the moose population in the Revelstoke Valley. So the moose population was building in the 1900s thanks to forestry. And we think that it peaked in 2003. And when I say peaked, it reached carrying capacity. So in other words, the moose population was bursting from the seams, and there was so many moose in 2003 and leading up to that, it had one of the highest densities in the province of moose. And foresters were observing that moose were browsing on the replanted trees. And there was also this really clear signal that calf-cow ratio, so the number of baby moose to the number of mama moose, was declining. And that, for ecologists, is a really clear signal that something is going on in the population, especially when the population is rising and we see those calf-cow ratios declining. So the blue is the population, and this has been measured and monitored by aerial surveys. So starting in 1994, there's been about 9 population surveys, which is one of the best understood moose populations in the sense of the surveys that have been undertaken, kind of thanks to the caribou dilemma at hand. And the red is the calf-cow ratios. So as you can see, it reached a low in 2003 because there was not enough food for these moose calves, and there was limited resources, and therefore moose calves were struggling. And in 2003 is when the provincial government enacted this antlerless moose season. So through a limited entry harvest, resident hunters were permitted to hunt cow moose and calf moose. And between 2003 and 2006, resident hunters reduced the population by about 70%. And that was known as what we call at least the reduction phase. And then from 2006 onward was the stabilization phase. And as you can see, and I'll get into this later, there was an interesting response in the calf-cow ratios that came with that. Okay. So for my master's, I wanted to, or I should say we wanted to understand what was going on with the moose habitat, specifically what age of cut blocks or what type of habitat were the moose selecting for most. So this is a really rich data set of moose, like I mentioned. There's been 46 GPS collars from 2004 to 2020. And that has allowed scientists to understand what is going on with this moose population. So we wanted to understand, like I said, what age of cut moose were selecting to understand their carrying capacity. So by identifying what age of stand they select for the most, we can connect that to how many moose the landscape can accommodate. Because as I mentioned, one of the only disturbance mechanisms in this system is forestry. Forest fires are not so much of a thing here. This is an interior coastal system. So it's in essence a rainforest. There's lots and lots of rain and snow. And so forest fires are, they're not much of a factor. And so we looked at these 16 years of moose data, and we did some statistical analysis. And we found out that moose, throughout an entire calendar year for all of those 16 years, they prefer cuts aged 14 to 36 years old. And Dr. Matt Muma and others, many of you are likely familiar with the provincial moose study, and they did almost identical study in the interior of BC, and they found that those moose were selecting cuts between 9 and 24 years old. And so back to our story, as I said, 14 to 36 years old was the age of cut that moose were selecting most strongly for. Moose were avoiding the fresh cut blocks, except for early winter. And they were also avoiding the older cut blocks. So when the forest gets to a certain state, when it gets to be, a certain height, and when the vegetation starts to fill in and the deciduous plants that moose rely on become suppressed, moose are not selecting that. And we've seen that across North America and beyond, with studies showing that moose really prefer those early seral conditions. So I mentioned the carrying capacity piece, and this was work that Dr. Rob Serrouya worked on for his PhD. So identifying that peak of the moose population. And as I mentioned on the forestry piece, logging peaked in the late 80s and 90s. And of course, there's a lag from when that peak happened in forestry to when there was that prime or optimal moose habitat conditions. So as a reminder from the last slide, we identified that moose most strongly select cuts age 14 to 36 years old. And we linked that age class of cut blocks to what the landscape can accommodate for moose. So basically, the cuts that are 14 to 36 years old all throughout the Revelstoke system, we identified that as the optimal habitat for moose. And therefore, we calculated carrying capacity from that. And how we calculated carrying capacity is we worked backwards. So we knew that in 2003, the moose population had peaked at about 1,650 individuals. And from there, we went back and we said, okay, what was the hectares of this optimal moose habitat, the carrying capacity? And in 2003, there was 25,000 hectares of cuts that were aged 14 to 36 years old. So from there, we came up with this number of basically this moose carrying capacity number of 0.065 moose per hectare. That, in essence, is the carrying capacity of this system. And so we were able to translate that and project that, which I will touch on in a second here. But here is the hectares of moose habitat, of optimal moose habitat from 92 to 2020. And as you can see, the story here in Revelstoke is that the moose habitat was declining. And the moose habitat was declining because the amount of early seral habitat conditions, so in other words, the amount of logging was being reduced, as I mentioned, for the two reasons of simply running out of timber to cut and some of those habitat protection measures for caribou. And so, as we can see, there's been a dramatic decline in optimal moose habitat, which is was part of the impetus for this research, because researchers such as Dr. Rob Serrouya and Dr. Bruce McClellan were predicting that this moose habitat was turning off anyway. So the landscape was becoming less conducive for moose. So through this moose reduction and stabilization program to help caribou, this moose population would have been declining anyway because the habitat was not conducive. So we perhaps may as well have taken advantage of that scenario and harvested moose instead of the moose declining on their own. So putting moose in people's freezers. And that's what this plot is in front of you here. So we know, I'll walk folks through this. So blue is observed. So that is the number of moose harvested in the Revelstoke Valley from 2003 onward, which was about 1,132 moose. And we know this through hunter survey data, that this is about how many moose hunters have been able to harvest and put in their freezer. And just as a reminder, this is resident hunters, so this is not including indigenous harvests. And from there, using our habitat, our carrying capacity model, we went back in the pre-reduction, the pre-moose reduction stabilization era, which was, we identified as 1994 to 2002. So between 1994 and 2002, the Revelstoke moose population was being harvested under traditional means that we're used to in North America, in the sense that it was a bull-only harvest, and we were harvesting about 2.5% of the population each year. So a relatively low harvest of just bulls. So that's what we refer to as our pre-reduction harvest. And so what we did is we calculated that there was about 2.5% of the moose population was being harvested each year. And we projected that forward as if no moose reduction and stabilization had taken place. So again, instead, the moose population was at 1,650 in 2003. And we used some simple models to basically say, okay, if no moose reduction or stabilization had happened, what would the population have looked like? And from there, we applied this 2.5% harvest on that each year. So that's that red, this red that you see here is the 2.5 fixed harvest rate. And the green was another hypothetical moose harvest scenario, because some researchers have pointed out that, if the Revelstoke moose hunt had not happened for caribou recovery, it's likely that the province still would have increased the harvest above this admittedly pretty low rate. But let's just focus on the blue and the red here. So the red is showing that if we would have carried on with the status quo of just harvesting bull only, or even if we harvested a little bit more, we actually would have harvested less moose than what the reality reflected. And the reason for that is because moose were, as we mentioned, declining anyway, or sorry, the habitat was declining. And there was also this really interesting response that happened, and that is the next slide. So as moose populations were being reduced for caribou recovery, again, 1,650 down to less than 400 individuals, we see this calf-cow ratio response start to change. So all of a sudden, as moose are being reduced from the landscape, there's more food available for these calves heading into winter, and there's no longer this competition for food. So what happened is that as more moose were being reduced from the landscape, we started to see an increase in the calf-cow ratios within the Revelstoke system. And so calf-cow ratios started to increase as the amount of food available to moose also increased, because again, there was simply less moose on the landscape, more food in the winter. And we started to see these calf-cow ratios rise. And so these calf-cow ratios, what ended up happening is they started to kind of backfill or compensate for the moose that were being harvested. And in essence, there was this moose factory effect that was taking place where, although hunters did reduce moose and stabilize them, because of the habitat conditions that now allowed more food for each moose, there was an increase in the number of moose that were being recruited into the population. And so this, in essence, balanced out some of those concerns that, moose were going to extinction in Revelstoke. Quite the opposite. There's actually a strong response from moose, from the calves. And we saw that, harvest was able to continue to be robust. The moose population indeed is not going extinct. And actually through, new levers being applied, such as wolf reduction, we're seeing that the moose population is further benefiting, and especially through wolf reduction, the moose population and the calf-cow ratios are increasing. And I also want to touch on, what this did for caribou recovery, which is another important question. And so this lever, the moose stabilization, we think stabilized the caribou population. As I mentioned in those early slides, they were at a low in the early 2000s, and this policy stabilized the moose population. And then when wolf reduction began, it really started to benefit the caribou population. And through reducing and stabilizing moose, it dispersed wolves. So wolf densities did decline in the Revelstoke system. And it also alleviated the pressure of, the government and it alleviated the pressure of wolves of actioning the wolf reduction piece as a sole measure, because as I mentioned, by reducing the primary prey of wolves, moose were able to, reducing the primary prey of wolves, caribou benefited as there was less wolves in the system. And this is another important figure showing that as that moose population got smaller, there was a greater percentage of calves being cranked out into the population. Again, because there's more food available for moose calves, and there was this strong response, and that's what you see here. So on the y-axis is calves per 100 cows, and on the x is the hectares of optimal habitat per moose. So as the moose population declined and more food became available to moose, the recruitment rates increased. So the last piece of the research that I looked at with my master's was, we understood what happened in the past and leading up to the present, but it's also important for managers, for, caribou recovery scientists, for indigenous peoples, for foresters, and for moose hunters to understand what does the future of the Revelstoke system look like for moose, for caribou, and for wolves. So what we did is we wanted to project these models forward. So we looked at the average amount of forest being cut between 2010 and 2020. It was about 610 hectares per year. And that is what we call our status quo logging scenario. And so from that status quo, we did a 25% increase. So a 25% increase from the 610 hectares, a 25% reduction, a 50% reduction, a 75% reduction, and a halt logging scenario. So all of these were basically predicated on, you see the time axis on the bottom here, but I'll go back to this one. So this is 2020. And this halt logging scenario basically says, okay, if we stopped logging in 2020, what would that look like for moose? And so as you can see, if we stopped logging in 2020, the carrying capacity for moose and their densities, which is reflected in these lines, would significantly drop through time. So basically from 2020 to 2040, which is just down here, the moose densities would be reduced almost to a natural state to where they were in the 1800s, prior to when people started disturbing the landscape. And if we continue with our status quo, moose densities will remain relatively healthy, but the reality is that logging is being reduced and the habitat for moose is also being reduced. And so this black line here is the threshold of moose density that is adequate for caribou recovery. So there's been some really awesome science that has measured what that threshold is, so what that density of moose is. And this all relates back to the number of wolves on the landscape. So the number of moose predicates the number of wolves. So if moose densities are at this level, then wolf densities will be low enough to basically satisfy a caribou recovery scenario where we don't need to be constantly flying every year and shooting wolves or applying other costly and politically tenuous levers. So here is the same figure with the years on the axis, which of course is helpful. And the previous one was moose density, and this is just wolf density. So the exact same scenarios. If we stopped logging today, what would that look like for wolf densities in 2040? And we know that by 2040 or 2038, that wolf densities would indeed be low enough to satisfy caribou recovery. But of course, a halt logging scenario might not be a feasible one, but it would be the most conducive to caribou in the sense that they would have the best chance of growing under a self-sustaining population status. Okay, so that was a lot of information, and thanks everyone for sticking through it, the take-home messages here is that this antlerless moose harvest stabilized endangered caribou populations, alleviated the dependence on wolf removal, and it included the public in this process. So instead of, the government strictly shooting wolves or maybe even shooting moose, the public was a part of this, and they were able to glean benefits, and they were able to put moose in their freezer. And if we hadn't enacted this, the moose population would have been declining anyway. So in essence, we were making hay while the sun was shining. And through that, again, we contributed to caribou recovery, and resident hunters were a part of that process. And moose exhibited, a strong response to this high harvest, and it created this moose factory-like scenario, which again benefited hunters. And the third and important take-home message is that the carrying capacity of moose, which again we define as those aged cuts between 14 and 36 years old, is on the decline anyway, and will continue through 2040 unless we see an uptick in forest harvest. So again, all the more reason to maximize moose harvest and to contribute to caribou recovery. And this is the question slide, but I'll also just mention that the next phase of this research, which is being undertaken now, is understanding the perspectives, the value systems, and the objectives of the Indigenous peoples who also hunt on this land. And that's something that Biodiversity Pathways is actively doing. Okay, it looks like it took a little bit longer than I thought, but Dr. Rob Serrouya will build on my presentation, and I will let him take it away.
All right, thanks Mateen. If you can unshare, there we go. Rob, over to you.
Right on. Do we still have time, or should I just cut it off here?
Yeah, we got time. Sure.
Awesome. Okay, well, it's always cool to see young, bright minds take over your work. So I hope to retire any day now. And looks like Mateen is pretty much ready to take over. So yeah, totally building on what Mateen talked about. And basically, this was Bruce McClellan's idea. So many of you might have seen his grizzly bear talk, what, about 8 months ago, was it, Jesse? Sometime around there. And everybody loved this talk. He gave a great talk. So if you don't like this talk, blame him and blame me. But yeah, here we go. Share the screen. Okay. So very similar question to Mateen. We are just building off it. This is also involves Mateen and Adam Ford. And Mateen used a lot of modeling, and if it was 2.5% versus what really happened, and inferring things. Bruce and I were much simpler thinkers. And we have a place where there was this moose reduction policy, so in Revelstoke, but we also have an adjacent area where that policy wasn't implemented. So we asked a much simpler question. Over this long time period, 20 years, did we sustainably harvest more moose where there was this Revelstoke stabilization reduction policy compared to a control area like the North Thompson where that didn't happen? So let's see, what do I got here? Right, so Revelstoke here, 2 MUs, like you said, 438, 439. This is 343, 44, and a few others. I can't remember what they're called down here, but basically the moose policy here. And let me turn off this phone here. That's my brother calling from Korea. And then the control area, the reference area. Now, what's the strongest kind of science? That's when you compare some, let's say you want to know if wolf reductions, wolf control increases moose populations. Well, you would compare what the moose population was doing before and then after the wolf control was implemented. But an even stronger thing to do is to have an untreated control area. And you also compare what happens in the non-wolf control area before and after at the same matched time as your treated area. So us nerds call that BACI, before after control impact. And that's essentially what this was. We compared moose kills per hectare of optimal moose habitat that Mateen defined in Revelstoke versus the North Thompson before and after with the control area. Yeah, that's what I say here. This is really simple. We just compared the number of moose hunted for optimal moose habitat in Revelstoke versus North Thompson. So this is what it looks like. And yeah, so we got Revelstoke here. This is the impact before the moose policy and after. And look, moose didn't go extinct, like Mateen said, and this is the North Thompson before and after, but it's a control. Nothing, no policy change, no major policy change happened here. And let's not forget, as Mateen pointed out, 1,100 moose were harvested here. They filled people's freezers from this time period. That's a lot for 2 small management units. And then the moose population is increasing here. So hunter harvest is increasing because wolf control kicked in around 2017, at 2017. All right, so let's do some statistics on this. And this is the predicted values of moose kills per hectare. Here I showed per 10 square kilometers. I just didn't have time to convert it. It's the same thing, moose kills per 10 square kilometers or moose kills per hectare. And this is the Revelstoke area before and after. This is just the results of a statistical model. And this is the North Thompson, your control. Before and after, there's no change in the control. But here you see a boon. It filled people's freezers. And again, this tested the idea that if we make hay while the sun shines, are more people's freezers full without driving moose to extinction. Like, it's not like all the moose were taken right away and there's no more moose. No, the population is still chugging along and it's still filling people's freezers. So yeah, we do a p-value of this. It's like right around hovering 0.05, 0.06. This is preliminary, but yeah, I did a statistical model and that's it. Simple thing. And that's really all I have to say. People's freezers got full and there's still lots of moose around, even though there was a relatively aggressive moose harvest policy because of that density dependence that Mateen showed, and because the forest was coming offline anyway. That's it. Thank you for listening.
Well, that was fast.
But informative, maybe? I don't know.
I've never heard it that fast. Okay, awesome. Well, we'll go right into questions here. I've got a few and you guys can figure out who's taking them. First one, what is the most effective evidence-based method of restoring caribou habitat which has already been disturbed?
I personally think restoring habitat is kind of bafflegab. HCTF, and maybe many people will hate me for saying that, but it's easier. A famous man once said, Fred Bunnell, it's easier to protect than restore. It's a lot harder to restore, and we don't even know if it works. We should try it, and we should do it in some concentrated areas like in the Clinziza herd, but we don't know if it works. So it's a heck of a lot easier to protect the habitat than have to go in and restore it once it's altered.
Okay, maybe I'll reframe that. Now that we've got some landscapes that have been completely marginalized, where do we go from here?
Okay, you reduce the rate of harvest, as a couple of our papers have shown, right? Because harvest is still accelerating in some areas, not in Revelstoke, granted, but in areas further north, in the central group around Prince George, and in the northern group, like in Tweedsmuir, Chilligatch's, Graham herd, those harvest rates are accelerating. But when you got a messed up landscape, yeah, you can rip out roads and replant them at $10,000 a kilometer. You know, it's going to be slow, even if you ramp up real fast. We don't have enough, you know, skidders and D8s to do that kind of work right now. Yeah.
Okay. Wolf population reduction has been identified as a lever to help reduce caribou predation. How much of an impact have bears and cougars have had on the caribou populations?
In the southern populations, particularly south of Highway 1, Trans-Canada Highway, but just around Revelstoke in Mount Revelstoke National Park, cougars have been the dominant driver of caribou decline, approximately, right? Habitat and climate are the ultimate causes, but cougars are the smoking gun. right around Highway 1 and to the south, not around Prince George, it's wolves. And then bears in the background, you got your bear tax. It's like just a flat tax. They take X percent, 5% of caribou. They take a lot of calves. And that's why maternity penning can work well if you protect those calves. The thing about bears, though, is we don't have any strong reason to believe that they're like 2 or 3 times more abundant than 100 years ago. But for wolves and cougars, we have stronger reason to believe that there are more of them in these caribou areas because of the ingress of whitetails and in some cases moose. You know, yeah, we're not saying moose, you know, moose were down here for sure. You know, Thompson saw a few dozen in Kinbasket. They were around, as Brian Glaikart is correctly reminds us, but they were nowhere near as abundant as more contemporary times. So bears, the bear tax is always going to be there. Plus, if you wanted to manage bears, you'd have to kill a lot of bears, innocent bears that have never tasted a caribou, just to save one caribou, because in some systems, there's actually more bears than caribou.
Okay, how transferable is this work to other landscapes, i.e. in the Northeast where they've always had moose?
I'll let Mateen tackle that one.
Yeah, so this effort was replicated in the Parsnip region, and the results were not as strong as Revelstoke. When I say strong in terms of stabilizing caribou and reducing those wolf densities, because the landscape is different. So the same goes for Northeast British Columbia. That's not the same funnel-like topography that Revelstoke has, where as the snow line comes down in the fall, moose are funneled to the valley bottom, and that creates a good scenario for moose harvesters to take advantage of that and harvest moose in the Revelstoke Valley. Whereas in the Parsnip and in parts of the Boreal, it's a flatter landscape, a more diffuse landscape. The moose densities are more diffuse and they don't congregate in those areas. So the ability to replicate this in the Northeast may be less successful than Revelstoke. However, it's still an important lever to pull, because again, it can reduce the reliance on wolf reduction as a sole lever. So it may not be as successful as the Revelstoke Valley because of the topography. However, it could still be a good lever to pull in conjunction with others to restore caribou.
Yeah, that's a good answer. I would add that there's less rationale to do so in the Northeast because moose were always part of the system in the Boreal. So there's just less reason to do it. Moose are known to be more recent inhabitants of these southern mountains. So yeah, there's less rationale to do so, but this is a big but. If you're gonna hammer wolves in those areas, it's not prudent to let moose erupt, because that's going to make things worse in the long term. So there could still be a win-win in these northern areas if government and or nations, First Nations, want to pull the wolf lever.
Yeah, and maybe even in those watersheds, like certainly in the Northeast and the Northwest, you had much higher moose densities. So I guess the question is, how transferable is it and what's changed? Maybe go down that path, because the Revelstoke thing is like low density moose populations, logging takes off, things go through the roof. Up in the Northeast, especially, you still have super low caribou densities in more remote places. So maybe just talk about those differences a bit.
Yeah, for sure. My colleague and buddy Craig Demars, who works with our team with Biodiversity Pathways, he's done some of the math that we did in Revelstoke, like growing back the forest, pretending the forest wasn't logged, and how many moose would there be. So we had, like Mateen said, 1,700 moose in 2003, 1,650. And if we pretended the forest wasn't logged, we'd have about 300 moose. So that's a huge change, from 1,600 to 300. In, let's say, central BC, around Mackenzie and further north, Craig's done some of that. And the difference is not that much. It's maybe, down by half or 40%. There'd be maybe 40% less moose, not 70% less moose. So, that question, whoever asked that question as well, yeah, they're thinking that's on the mark for sure. Moose, caribou, and wolves have coexisted in the Northeast, but it's been a different mechanism, we think. You'd have these big burns, then moose would move in, other ungulates, elk probably in the Muskwa, caribou would then suffer because more predation, but they'd exist somewhere else. They might blink out here when the wolves take over, but they'd exist here. But then this forest would grow up and the moose and elk would decline, and then the caribou would recolonize here. So in that natural system, there'd be this dynamic thing going on. Of course, that's not happening as well anymore because we got roads and seismic lines in the Northeast. So we got less of this apparent competition thing that Mateen talked about and more of this ease of movement thing going on for wolves. So it's complicated. There's not just one story.
Okay. Is there a risk of overharvesting moose in BC given the reduction in habitat and carrying capacity? More properly, given the resurgence of moose following aggressive harvest policy, what would it take to overharvest them?
I'll let Mateen tackle that.
Yeah, so there's certainly, throughout the province, and we always want to emphasize that, this research is Revelstoke, and we are aware that throughout many parts of the province, moose are in decline, such as the Bonaparte, and many other regions of British Columbia. And there certainly is risk of overharvesting moose in those systems. What was the second part of that question, Jesse?
It was, given the resurgence of moose following aggressive harvest policy, what would it take to overharvest them?
Right, yeah, so I mean, overharvesting them, when harvest is unsustainable and it's above, say 8%, 6 to 8% of the population, and you're harvesting adult females, that can be unsustainable. Pair that with a habitat that is less conducive to moose, thanks to pine beetle and overharvesting of the forests, high predator densities. It can be a perfect storm for crashing moose populations. However, the good news is moose are a relatively fecund species. So fecund meaning that they're able to, reproduce at high output. So like caribou can only have a single calf, and moose can crank out twins. They're a lot less needy than caribou are. So moose can bounce back. They need those habitat conditions. So I would say that we should be optimistic about moose populations in British Columbia, because they certainly can make a comeback with good management practices, from the bottom being the land and from the top being predators and hunting. Yeah.
Okay, a couple of similar questions. I'm in a batch here. What reducing moose populations and the changes in the landscape, I guess, has there been an increase on whitetail deer, mule deer, and caribou habitat, and what does that impact have on predator populations? So are you seeing that north of Revelstoke? I know you got a bunch of deer collared.
You're seeing that, Jesse. Yeah, we do have a lot of whitetail deer monitoring going on north of Revelstoke, because the worry is that with the wolf reduction and cougar reductions that are going on, that whitetail will expand, even though we're managing to keep moose stable. Again, I would say that the government is doing an awesome job of a sustainable moose harvest there. Like, it's well managed system, like carefully managed. I am more worried about the deer, the whitetail, which first appeared in Revelstoke in the 1960s. We had a big interview process of folks in about 2003. We had a whole bunch of old timers and knowledge keepers that Cindy Pierce organized, and the first whitetails were spotted in Revelstoke in the 60s. and we've got cameras set up. We got a deer program going on, deer collaring. Whitetail survival is high, very high from the radio collars. And yeah, it's a worry. I've never seen tracks on the west side, like this number of tracks on the west side before. And I know, Jesse, I've seen you talk about it as well when you're up there. So yeah, they're getting in some pretty cold, dark places. So that's not a good thing for the long-term persistence of mule deer or caribou if those whitetails get a foothold.
Okay, this follows up on the first question. It says the cost of culling is also a huge commitment. Is this sustainable and the future of caribou habitat restoration, if it's a waste of time? So I guess the question is, it's better placed as what do we do going forward to make sure that there's caribou on the landscape 100 years from now?
I think the most important thing is, first and foremost, reducing the amount of habitat loss and increasing the amount of habitat gain. So we can't continue to be losing habitat because that is just punting the problem further down the road. And yeah, it is a daunting concept to think about what caribou will look like in 100 years. But, as we've seen through case studies like the Clinziza population, where West Moberly and Soto, an Indigenous-led effort with collaboration and partnership with the provincial and federal governments, they have been able to recover that population. And indeed, there will be longish term need for predator reductions to ensure that caribou are continuing to grow. However, that is just a part of the system and a part of caribou, and whether or not that's sustainable, that's a value-based question, I would say, that varies across the spectrum in British Columbia.
Thanks, Mateen. Okay, this one, have either of you studied effects of glyphosate on moose habitat?
Yeah, I don't study that.
Yeah, there hasn't been a whole lot of research on that. However, there, is research that shows that deciduous forests are important for moose. They're important browse. They drive moose populations throughout Canada, the deciduous forest. And yeah, so I think research on that is still emerging, but deciduous forests are really important for moose.
Got it. This is a whitetail comment. We're kind of jumping around species in region A, noticing a huge increase. Are you aware of a management plan to reduce their population? Either of you speak to that, or is that outside of your?
I am not aware of a management plan, but we write about it. We publish papers on whitetail emergence and links to caribou. Like personally, I'm not against, I'm no problem with whitetail. They're great. Like there's my antlers right there. Can you see it there? See, there they are behind the couch. Like hunting whitetail, no problem. But they should be in some areas, sure, maybe Cranbrook and the Trench and these other areas, but if they emerge and expand into mountainous caribou areas, it's not going to be a good thing for caribou. We know that from Alberta. The science is super strong in Alberta. The expansion in whitetails caused a numerical increase in wolves. That's David Latham's work. And that caused a decline in caribou. So, yeah, a precautionary approach, speaking of management plans, like this is a scientifically defensible statement, would be to greatly liberalize whitetail harvest in management units that overlap with caribou. That would be a prudent approach. And I don't mean like, going from, October 11th to the 31st or whatever the season is, 9th or something. But like February, if we're serious about preventing a foothold of whitetails in areas where they are expanding into, if we're serious, if that's a serious lever, 12 months a year, no bag limit, and people will send me hate mail for that. That's fine. But I'm not saying that everywhere, to be very clear. Montana, whitetail heaven, right? Montana folks love hunting whitetail. They have a February doe season for whitetail to stop chronic wasting disease spread into muleys and other critters. So it's not like it's, sacrilege to mention this. It's happening in Montana. They have a February season. So it's something I think that BC managers should consider.
Okay, thanks. I'm all out of questions. You did mention Alberta. Maybe you want to just give us a quick rundown of the Little Smoky, or what happens there when you get to a landscape that's been completely marginalized, and what that looks like.
I wish I had some graphs handy to show you. I could, but yeah, I mean, they can barely keep on top of the wolf management there because the habitat is so disturbed and accelerating. The disturbance rate. If I could think fast on my feet, I could show some graphs, but let's leave that for another talk.
Yep.
More of a habitat talk. But yeah, they can't keep on top of their so yeah, when the amount of landscape disturbance gets to a certain level, you can't manage using the other levers. So the caribou population growth rate in the Little Smoky is just hovering at 1, despite wolf control that has been going on since 2005. So much longer than in BC. The wolf thing is pretty new in BC, 2015 wolf reductions for endangered caribou, to be specific.
Okay, well, that's great. That's an hour. So awesome. Thanks, Mateen. Thanks, Rob. Thanks, Philippe, for doing all your work in the background. We really appreciate your time. As said, for everyone who's tuned in, this is for your knowledge, education, and for you to use as you talk with your friends and your coworkers and meet with your MLAs and your MPs. Always nice to have two, researchers that are on top of things that have spent a career on it. The next conservation webinar is going to be May 24th with Chloe Wright from UBCO. She's going to give us an update on the Southern Interior Mule Deer Project, understanding mule deer migration in South Central BC. Hopefully we see all of you then. Thanks, Rob. Thanks, Mateen. Hope you guys have a great week and that everybody gets to go out and enjoy the sun. The heat's finally coming.
Thanks a lot, Jesse, for inviting us.
You bet.
Thanks, Jesse. Thanks for listening, everyone.
Thanks, everyone.
Thanks. Good night.